Dihybrid cross problems are the next one I want us to look at. And a dihybrid cross problem we do a little differently. Well, kind of differently. We do the same thing, but we do it twice. I know last year you learned how to do the 16 square Punnett square, where you drew this huge 4x4 block out and you counted them. Well, I'm going to teach you a faster and better way to do these problems here in advanced biology, because I think we're at that level. I think we can understand that. So here's our thing, our problem. It says a heterozygous tall white flower is crossed with a homozygous short heterozygous violet flower. What is the chance that the offspring will be a tall violet flower? Okay, so that's our problem. The first place I always start with figuring out the parents. I want to know what we're crossing, and I want to know the genotypes of them. So right here I'm giving you phenotypes, tall, white, and then over here I'm giving you violet flowers. So these are all phenotypes, but I want to know their genotypes, what letters they have. And I'm going to use T's and V's. Doesn't matter what letters we use, but I'm going to use T for the tall gene and V for the violet gene because violet's dominant. So if I look at this one here, it says a heterozygous tall white flower. Well, I'm just going to deal with heterozygous tall. Heterozygous tall, I know looks like big T, little t. Okay? White flowers, I know look like, is the only way to get white. That's the recessive. So I need two little v's. Little v, and I'm going to put tails on the ends of my v's so you can tell that they're little v's. And we're going to cross that with a homozygous short. So the only way to get homozygous short, and short's the recessive, is little t, okay? And then a violet, and then a heterozygous violet. So I have big V, little v. Now, those are my parents. So this parent is heterozygous for the tall, homozygous short. This one is homozygous violet. This one is homozygous short, heterozygous violet. So now I've figured out the parents. Now we need to solve this problem. What is the chance that the offspring will be a tall violet flower? How I want you to encounter these problems is this. I don't want you to draw out a big Punnett square and attack it that way. I want you to look at each trait at a time. So all I'm going to look at first is the T's. So I'm looking at just this gene. And I'm going to do a Punnett square for just the T's. Okay, so I'm going to do that down here. I'm going to make up a Punnett square for just the T's. And I have this parent I'm putting up top, so I got big T, little t. Right? That's that parent's T's. I'm ignoring the V's. I'm not even looking at the V gene or the violet gene now. I'm just looking at whether the plant's going to be tall or short. And over here I'm going to cross. I'm going to put this parent over here. Whoops, I don't know why they're disappearing off the side there. Wow. Okay, so this is going to be little t. Maybe I can write it over here. I'll write it over here. Little t, sorry about that. I usually write them on the left side. So now if I cross this one's big T, little t. This one's little t. Okay? This one down here is big T, little t. And this one down here is little t. So I know that half of them are going to be tall and half of them are going to be short. So I'm going to look over here. The question I'm answering, what's the chance that the offspring will be a tall flower? So I'm carrying just about tall right now. So I know that over here, the only two that are going to show up tall are these two to the left. So I know that I'm going to be half of my flowers are tall. Now, we're done with the tall. We've decided that half of them are going to be tall. Let's look at violet. Okay, so if we do the violet gene, I'm going to do the same thing. I'm going to create a Punnett square over here for the violet gene. And I know that this parent here, I'm going to write here, so I have two little v's, little v. And over here, I'm going to put this parent down here, and I'm big V, little v. So if I cross this out, I have big V, little v, big V, little v. And down here, I'm little v, and little v. So now what I have is I have a Punnett square for just the violet trait. And I know that this child is going to be and I'm looking for violet. So I care just about violet. I know that I have 50% of them. 50% of them are going to be violet flowers. See if I can change my ink color. I know that these up here are going to be my violet flowers. So I know that 50% of them are violet flowers. So if I do this again, that means half. And I'm going to write it as a fraction, so I have half. Now what I have is I have this problem. I know that half of them are going to be violet flower, or half of them are going to be tall, and half of them are going to be violet, but I need to figure out how many are going to be both tall and violet. And what we do is we multiply fractions. So I take 1/2 times 1/2. Okay, and you multiply across the top and you multiply across the bottom. So 1 times 1 is 1, and 2 times 2 is 4. So I know, when I look at this, my fraction is 1/4. The final answer is 1/4. 1/4 of these plants are going to be both tall and violet. And I did that by doing 2 Punnett squares, 1 for each gene, and then multiplying the fractions, multiplying the results. That's how we do a dihybrid cross. I may encourage you to watch that again and just take a look at it. If you have any questions, please feel free to ask me. I'd love to go over these with you in class. Once again, we'll get lots of practice in class. So if you have any questions, ask me. Thanks, team.